morning. Welcome to this lesson on how to build large language model from scratch. So in this lecture, I just want to take you through the whole thing. I just want to show you the whole stuff we are going to learn throughout this class. Let me just show you what you are going to learn. I have already implemented some code, as you can see here in Google Drive. So let me import something to this place. That's what we're going to use and train this. I will still show you what the thing is here, but let me just import it inside this. Okay, so in this thing, we're going to be using Pidgin dataset. That means a dataset that I got off from the internet. It is called Pidgin. I name it Pidgin dataset. At the time now uploaded. So I've imported the whole thing here. So what I will do is that I'm just going to take you throughout the whole this that I've created, so that you know what we are going to do. Maybe when I start teaching it, I will not teach it in full. Let me just show you what we are going to do. First of all, to start any data training or training of any GPT, you have to import all the whole data sets that you will use in training it. In our case, is this data set here that we are going to use and train this. It is called Pidgin final data set. Let me just show you how the thing look like. So let me show you how the thing look like. Let me show you how the thing look like. Wait, let me minimize this place and show you. Okay, so look at how this is how the Pidgin dataset look like. See this here. If for better said then kill me, they forgotten what they destroy woman. They forgotten what they destroy woman lives. Know yourself. Be the first to get latest story, analysis, exclusive interviews. Okay, so this thing is all about news. I imported this dataset from BBC News Pidgin and other news outlets that write their dissent in Pidgin. See this one: top military officers with Boko Haram and ISWAP don't kill for terror war. I imported the whole dataset from all this online BBC News. If you want the code to import it, I will also share the code with you guys, but I'm just showing you how the dataset look like. So let's go back to Google Colab and then so first of all, you first start by describing the file path. As you can see, describe the file path. Then this part points to this dataset, so that anytime I run this, it will open the file path and then read it, then print all the whole data. I'm just printing the last word where they did. The last word that is here, the last thing that is in the last word that is in the data set. Let me run this study. And say in for better said they kill me. They are forgetting what they destroy human life. Know yourself. Okay, so the last thing that is there. So and then second step is to convert everything to token. Computers, or should I say machine, or these computers, they don't usually accept words as their input. So first of all, you have to convert it back into numbers, so that computers can work with it. If you leave it in word format, if you leave it like this now, computers will not be able to understand what it is. So you have to convert it into data. That's what I'm going to do here. So I converted this thing into data. So after converting it, you will see that it has 600 characters. It has 16,128 characters. That means words in this thing, the AI is up to 616,126. That's how many words there. Then if you convert it into tokens, there is difference between words and token. Token converts the distance. It does not convert it word by word to to numbers. It looks at how the algorithm detect converter. Maybe when I'm teaching about token this, I will show you how the thing converts the distance. But for now, just know that it converts every word here into token. So it is not likely to be a word. The token is not likely to be let me say E go be 1 for go be. This is how this thing looks at the word and convert it. So that's what it did here. Let's print out one this thing. Let me write a code that can print out a word inside that place so that you will see. For example, if I say something like word, if I write a word like this and say words equals to, then I come here now and collect any word here. Let me say I come here now, come copy this word now. Then I copied this word into this place now, into this my word this thing. Then now if I want to convert this thing, I'm not saying then if I print this thing now, if I print the word that are now converted into tokens, look at what you are going to see here. Let me run this cell again. Then have you see it's converted all the word here into numbers. Like now how it's converted into 204. The word is converted into 2437. Then the next one, which is people, is converted people. I don't even know how to pronounce this in this page. So people now is converted into to 7,347. So let me convert this thing back again into let me convert it. Then let me convert it back into where, so you can see how the thing works. Let me limit. Then if I now run this cell now, and you see it has converted the where all these numbers that converted the numbers back to the word, how the word was before. So that is how this thing work now. Then let's go to another section. This section is all about loading this thing now into the GPT that you are going to create. How this thing work is that it creates a dataset. The dataset will contain the real word and contain the input, the word that you're going to feed into this and the target word. The target word is just like something. Let me see. The target word is what is going to the LLM is going to look at and then know whether the word that he is predicting is either wrong or correct. Or not wrong. So the target word, this target ID is going to contain the original word. So this input now, if you input it into the LLM, it's going to use it to check whether anytime the LLM predict a word, it will check between that word that he predicted and the word that is in this target ID if they are the same or not. If not, then it's going to do what they call backward propagation to correct all the whole distance to make it look the same. So but if you can see here, this batches this stacks the whole input into many distance. It stacks it into batch size of 4 rounds. Let me show you something here. Then this one can be first batch, first batch, second batch, third batch, I can use this one as my first batch, this one second batch, third batch, or I can use this 4 inputs together, this 4 as my first batch, or I can use only one as my first batch. It depends on how you want to run it. So as you can see here, so this is how the code works. You don't need to like I will explain all this code later, but now I'm just like trying to show you how the whole thing works. So this second one, so this second one now, let me run this cell first. Let me run it. Let me see. It has finished running. So this one now, I want to use this thing to like this thing is just the architecture of the GPT that you are going to create, and then this thing is 124 million parameters. That means it have up to 124 million trainable ways, all those connections. It is up to 124. The same thing with GPT-2, all those kind of things. GPT-2, that this have the same architecture as that of the GPT-2. ChatGPT, the first version, that which is GPT-2, the lower model, it will have the same architecture with it. So that's just it. Let's see another one. Okay, this one now is used for the training and the validation, to learn. Yeah, you are going to use this first one is used to load all the whole data set. This one now, it is this code now that will load them into the architecture, into the GPT, so that it is going to process those numbers. And then validation dataset, this is like the validation dataset is used to just like, let me say, check the same thing, like check whether what the GPT is predicting and the real whether they match or not, so that it can perform backward propagation and then correct it. Then backward propagation is just like trying to learn from your mistake. Then if the GPT make a mistake, it will then do backward propagation to correct the whole mistake. So this is just how the dataset looks. Let me run this code again so that it will. Again, I'm not finished running this one. I want to run the second one. I'm never running this one. I want to run the second one. Okay, this one I've run. This one I've run. And this one I've also run. So this is what the thing is printing. Good. So let's load it. Now how you see, it's a half trillion token. The token is up to how many? 132,607 for the training. For the training, this is just used for the training, and then this one is used for the validation. It's used to like check whether it is correct or not. Good. So this is where the whole thing come up together. This is okay. This is just for the multi-head attention. Let me show you according to that book, according to that attention, this thing that I shared that day. That book that I shared to you guys about the LLM architecture. So yeah, this is where we are now. Not yet. So this one. So this is where we are. First of all, we have created an input. This is the input. Let me show you. Let me just. We have created an input here. What's this page? We have first of all created an input. This is the input here. Created an input here from this place. Input. This is input. So, and this is the input here. This is what you are going to feed into the LLM. This is the input. This whole thing here. This whole code is the input. Don't worry about the code. I will still like teach how the thing works here. So this whole code, that's the input. Then where we are now is here inside this place. This thing now is also inside this. You are going to create the whole thing inside here. So where we are now is here inside attention. You can see multi-head attention here. This is all about everything you need to know about multi-head attention is here. And don't worry, I will also teach all this thing from scratch. Then you will know about everything that is in this place. But for now, you just know that here now is this place is this multi-head attention is here. So another one is layerization. The another one you have to know is layer normalization, which is here. This layer normalization is somewhere here. Yeah, as you can see, this thing is repeated. So it depends on how many multi-head attention. That's what I described here when I saw you when I told you about the LLM architecture. Look at here. Yeah, now number of head is 12. As you can see, this one is only 1, 2, 3. Then this our own is going to be 12. The same thing with transformer. The transformer is 12. The transformer is this thing now. What we call the transformer is all this thing here. This thing here now is the transformer model. We are going to make this thing 12. That's what the number of layers is 12. That's what the number of layer here is 12. Then number of attention heads, that means how number of multi-head attentions is also going to be 12. That's what we did. So input embedding is 768. Each one word like this now, to project it into 768 dimensions. All these things are just, when I'm trying to like teach it, I will explain everything better. For now, just know that they are going to project one word into 778 places. Okay, so another one is this now. This feed forward. This look at where I created a feed forward. This one is the transformer block. This one connects everything. Look at the feed forward class. This is the feed forward class. This thing is just for here. Then as you can see inside this place now, all the whole this in here is being, look at it here, transformer block. It contains everything that is going to happen inside this place, from the multi-head attention, as you can see, from the multi-head attention to the feed forward, then to the layer normalization, which is this one, and then it is going to return the logit. It's going to return this. The final output is going to be a logit. Then probabilities, if you can see here, they name it. It is called probabilities here, but it's usually called logit, but it's the same thing. Both logit and probabilities, it's the same thing. So let's go back to the course. Okay, so let's run this cell. I don't know that I finished on it. Okay, first of all let's run this one. Then let's run this one. Then let's run this one. Then let's run the transform. Okay, it's not finished running. So this is the GPT model. This one now, this model now contain all the whole on the cell now. It is going to return logit instead of probabilities. I just name it logit. The logit is like more widely used than probabilities, so that's why I name it logit. So let's create the GPT model using this architecture. If we run this thing, it's going to create the whole thing using the whole architecture. It's going to finish creating. So for now, let's just generate a simple test. Let's just generate some simple tests using what you just created now. Without data, I've not undergone any training. Let's just generate something. Let's just generate something. Okay, so let me show you something. Look at what you are going to start with. If you put this thing inside the model, this word now inside the model, then and tell it to predict maybe the next you are going to tell the model to predict the next 10 words that's supposed to come after this one. Then if you run it, look at what it's going to predict. Oh my guy, half it's some randomly unkept word, some messed up words. That's what this thing is predicting, because they have not undergone any training. But after training, you will see that this thing is going to be predicting correct and clean word to be used. So let me change this thing to another thing so that you just show you how the thing works. Let me say in the my G, and then if I come here now and say let's the thing predict next 20 tokens, 20, that means it's going to predict 20 words after this one that I provided here. So if I run it, give it some time. good. Have you seen some random, yeah, no nonsense words that is writing? So over this block now is where we define calculation badges, loss, and all those things. Yeah, this is going to like calculate how many times the model is wrong. This is just what the model is trying to reduce, the number of wrongs the thing is, how wrong the thing is. Yeah, the model will just work hard just to reduce how wrong it is. If the number is big, that means the model is very wrong. But as the number trying to get lower, that means the model is learning and also going to be likely going to predict a very clean word. The next time, let me just run this to show him. This is how we calculate the loss, like how wrong the model is. So here now we are going to print how wrong this one that we have created now without training, how wrong it is. Let's print it here. Boom. Yes, it will likely take some time, some pretty big time to run. Let's wait to it. I'm going to edit all display. That is going to take a long time so that you know how to do. Okay, so it have run, finish. You see training loss, the loss 11 point something. Yeah, see how wrong the thing is. Then validation wrong. See how wrong it is. The whole essence of doing all these things is just so that this model can reduce this loss to the minimum. So just reduce this 11 to something like 0 point something. So that, let's run this cell now. Okay, I finished running. Let's generate another this block now. This one now is used to generate, like, if they during the training, this thing now will be generating word to like show you how it is learning through, like as it is learning, it will be generating words so that you know how good the thing is becoming, something like that. So now this is where the whole training starts. If I run this code now, the thing will start. Okay, not this one, but this thing define how many times you want to train it, how many epochs, all this thing. You don't need to know it now, like, but this thing is just used to describe how we are going to train the model. So let's run this with definition. So this is here where we train the whole model. For now, let's train it using train it 20. So you guys will know how what it have learned and all those kind of things, maybe whether it is learning or not. So let's just go ahead. We started with hunger day Naija. That's the word we gave to the LLM to like predict how many words, to predict up to, yeah, let's check. To predict up to 50 tokens, up to 15 tokens. To predict up to the next 50 tokens. That's what we give to this thing. As we give him this word now to produce, to predict up to 15 words that is likely to come after hunger day Naija. So yeah, let's take a look at the training stuff. So for the first epoch, let's check. For this first training epoch, the first one, it started training, and then after, as you can remember, the training was at, let's check here, the training loss there. And the training loss was 11.000 after we calculated the distance without training. Then after the first epoch, the thing reduced from that, then from 10 something, that 11 something, to around 1.108, and the validation loss to 1.06. 8. Then the thing predicted after the model predicted that Hunger dey Naija reacts to the the thing is still not making sense at this stage. Then after the second one it predicted, then as you can see the words here have started to like make sense or resemble the ones in this data set. Let's to look the same as this one that is in this place. As you can see, all these words here have started to look the same with that of the one that this one is predicting. So let's close this thing. Okay, so after around the third one, as you can see, the thing is making a lot of sense here. As you can see, so Hunger dey Naija they had to risk some champs to make champion or this kind of thing. So after the sixth one, after the last training, because we set this thing to train for 16 months. So after the number 16 you see Hunger dey Naija reacts to risky new song. Hunger dey Naija reacts to risky new champ song. So if you look very well, you see that this thing now is not like predicting as. So as you can see, we have let's check this thing. This the model. This code here, we use this code here to save those architecture, those learning. See here, those after the thing finished learning, I have to terminate this one. The thing started running again, so I have to like they took the light, so the model started running again, started afresh. So I have to like terminate it because I already saved that one that run for 20 epochs. I already saved it in my I already saved the weight in my file, so I have to like import the whole weight again so that I can use that first weight and then run the second one. I can use that first weight and then I can use it to run to show this example. So let's show this example. Let's test it with this example. Alpha you they go school today. So if we run this thing now, you will see that he said Alpha you dey go school today. Fatima Bosch of Mexico wey waka comot on organizer win Miss Universe. And if you notice, you will see that this whole thing is just like printing, should I say copywriting from all this thing now. It's just like instead of the thing predicting the next word, it's just like copywriting from this thing. This is to show that our model is doing what they call overfitting. Instead of the thing to learn, it is actually copying from the training data. It's actually like it's just like doing photocopying work, just copying from that thing that they use to train it and then bringing it back. Because if you can see, you see that Fatima Bosch of Mexico wey waka and organizer Miss Universe. So if you come here, if you come to this place and then look it up, Fatima, I don't know that you say where I can search this thing up. Fatima, because this thing is very big, the data is very big, so I don't know whether I can search it up. But that's just the thing. The thing is just like printing from this thing and then okay, I see Fatima for you. Fatima. See I'm here. You see that, look, you see that this is just like copying Fatima Bosch of Mexico wey waka comot on organizer Miss Universe. On organizer Miss Universe. This is just the data set. This is the data set. So if you see that the LLM is just copying this thing and pasting it because he thinks that's the next word he predicted. But let's try to do something so that if anytime we run this thing, instead of the thing to just like copying and pasting, it will actually be doing the normal prediction work. Then it will just like predicting the next token instead of just copying from the whole data set and pasting it. So on this cell. So This I finished running. So let's try to generate another one. What do we use in that first one? Let's see how it will predict. It's not that it is not predicting or, but it is actually one. Let's use the same manner so that we use here. Alpha, you dey go school today. Let's use that. Alpha, you dey go school today with question mark. Let's use this one. I cannot find question mark on my keyboard, so let's just run this one. Okay, so as you can see, the thing has started acting like a news article. You see here, Alpha IG, you go school today. Life imprisonment after for Kwara. Top military officer wey don see am. The thing is actually predicting the next word. So, but some of you might be asking, how is this one now different from that first one? Okay, how the thing is different is because we use what they call multimodal. Yeah, multimodal is this one function they call multimodal, and also we use things like temperature and then care, nearest neighbor, those kind of things. We use their functions that they call top k and then temperature. This thing is used to like determine how many tokens the thing will predict, how many top tokens the thing will predict according to the temperature. The more you increase the temperature, the more the thing predicts sharper this one. But if you increase it well, the thing will not like get enough. It will just focus on one token that he thinks is the most appropriate. But if you use like temperature around 2 point something or that kind of thing, it will actually have a range of words that the thing can predict from. So that's why this one now is more better than this first one, because this first one is actually just copy pasting from that data point to its own distance, instead of the thing to learn to be predicting or to consider a range of words. It's actually just predicting, taking the one that with the highest probability and then pasting it here. But with this new top K temperature, the thing will actually look at some range of words, and then each time you run this code, it will actually try to predict words that are in the same range or at the same range or top. Like if they have words like come, let me find word that I will use, like something instead of the thing to predict. Anytime you say I won't come your house, or the thing will predict something like I won't come your house. If there's no like temperature or top K, the thing will just be using I won't come your house, I won't come your house. But if you increase temperature and use top K, the thing will actually be considering things like I won't reach your side, or more ma come your side, or ma reach your side, or ma track you, that kind of thing. So that's the difference between this first function here and the second function here. Then in the next class, I will try to start from the basis. That means I will start from this one now. I will go in detail about how all these things work, and then the tokenizers. I will talk about different tokenizers that they have and why we use this tick token on to tokenize this word. So that is how the class is going to be. And I don't know, you can actually, I don't know where I will post this, maybe only in this group or somewhere else. But if I post it anywhere else, I will tell you guys, so that you guys can actually just go and give me a likes, or you can follow me, that kind of thing. But that's just the main purpose. So as we have increased the new token to 50, and then we have increased top K to 20, then let's run this thing. As you can see, the thing say how far you dey go school today. For 3 members of Miss Go, we work out come don't kill them don't kill me. They forgotten what you be stating that they So you can see we actually train this in using news articles. So it is going to be based on that news articles. It's not going to add new word or new, and it's just going to be doing as, it's going to be acting as news outlet. You know how they give news for Pidgin now. So the thing is just going to be like trying to mimic how they give news in Pidgin. Let's increase the top K to 4.0, and then yeah, temperature to 4.0, and then reduce top K to like temperature and all those kind of things. But they have like ranges. You can like check with other distance. You can check with other top Ks and other distance, so that you can like see the one that fits the model the most. I think temperature is 4 because I increased the temperature to 4. It started misbehaving. Let's reduce this to 1, and then 1 again. See. How far you go school today? 14 hours school physical. We work out, come out and organize and win. See, and this one actually makes a lot of sense. You know, that's the end of the class. This code here that I commented out is just for saving and downloading this model in case maybe you want to run it on your laptop without internet connection, because I'm using data, as you can see from here. I'm using data to run all those things, and because I don't have GPU, my laptop don't have GPU, so I'm using data to run all this thing with using Google Colab. So that's all for this class. See you next time when I start going in details about how everything works. Thank you, and then thank you for watching. Bye bye.